Did we already start this streaming? Okay, we already start live. Okay, hello folks, come back again to my YouTube channel, and right now I'm still trying to learn about Motion Canvas instead of forcing myself to create the animation from scratch. I think it's better to know what is the functions mean. So turns out I used to try to learn about the Nature of Code by Daniel Schiffman. So I need to learn about the vector and some of the other things. I think the Nature of Code is from Coding Train, right? If you don't know, the Coding Train is this guy who create some coding challenges using P5.js. And basically what he did is how to use math and also how to use computer science to get the solution from the problem that he tried to solve. Okay, let's relook. Acknowledgement. The world around us moves in complicated and wonderful ways. We spend the earlier parts of our life learning about environment through perception and interaction. We expect the physical world around us to behave consistently with our perceptual memory. For example, if we drop a rock, it will fall due to a gravity. If a gust of wind blows, lighter objects will be tossed by the wind further. This class focuses on understanding, simulating, and incorporating motion-based elements of our physical world into the digital world that we create. Oh, that's great. Incorporating motion-based elements of our physical world into the digital world that we create. Our hope is to create intuitive, rich, and more satisfying experiences by drawing from the perceptual memories of our users. James to Dynamic Bodies course description, Spring 2003 ITP. Okay. In 2003, as a graduate student at the Interactive Telecommunication Program ITP in the TIS School of the Arts at New York University, I enrolled in a course called Dynamic Bodies. Okay, this one. The course was taught by interaction designer and ITP adjunct professor James Tu. At the time, I think I need to zoom in a little bit, so if you watch my stream, you can read it as well. At the time, my work was focused on a series of software experiments that generated real-time, non-photorealistic imagery. The application involved capturing image from a live source and painting the colors with elements that move about the screen according to various rules. Two scores which cover vectors. Oh, that's great. Forces. What is the forces? Forces in math. In mathematics, especially in mechanism, a force is a vector quantity representing a push or pull, defined by both magnitude. I think I've already learned this, but I'm an Indonesian people, so I don't know the term of forces in math. Forces in math in Indonesia. This one is forces. Okay, great. Okay, this was great. I think there is some people watching my live stream. Hi there. Let me continue the article of Nature of Code. Oscillation, particle system, recursion, steering, and springs. I know springs align perfectly with my work. I had been using these concepts informally in my own projects, but had never taken the time to closely examine the science behind the algorithm or learn object-oriented techniques to formalize their implementation. That very semester, I also enrolled in Foundation of Generative Art System, a course taught by Philip Galanter that focused on the theory and practice of generative art, covering topics such as chaos, cellular automata, genetic algorithm, neural networks, and fractals. Both Too's and Galanter's courses opened my eyes to the world of simulation algorithm, techniques that carried me through the next several years of work and teaching, and that served as the foundation and inspiration for this book. Okay, this tell about this guy tried to learn object-oriented techniques to formalize their implementation, but in JavaScript, yeah, maybe we can use object-oriented later. I think this motion canvas using object-oriented under the hood. If we look, it is class. Yep, it's class-based. Yeah, so I think it's related to what I need to learn more in depth about motion canvas. But another piece of the puzzle is missing from this story. Galanter's course was mostly theory-based, while Too's was taught using Macromedia Director and the Lingo programming language. Oh, I don't know about the Lingo programming language. It is object-oriented, yep. Lingo is a verbose object-oriented scripting language. Lingo Adobe Director scripting language. Adobe Director. This one. That semester I learned many of the algorithm by translating them into C++, the language I was using quite awkwardly at the time. Well, before C++ creative coding environment like OpenFramework and Cinder had arrived. Coding environment like OpenFramework and Cinder had arrived toward the end of semester. However, I discovered something called processing. Processing was in alpha, then version 0055. And having had some experience with Java, I was intrigued enough to ask the question, could this open source, artist-friendly programming language and environment be the right place to develop a suite of tutorials and examples about programming and simulation? ITP and processing communities, I embarked on what has now been an almost 20-year journey of teaching coding. Oh, really? I don't know that the coding train. Yeah, it's already 20-year journey. Coding train YouTube. Oh, it's 10 year. But still, this guy is still insane. 10 years ago, they created their first YouTube video. And until now, I think, yeah, it's still 2 months ago. It's still active. He's still active, create the YouTube video. I'd like to first thank Red Burns, who will led ITP through its first 30 years and passed away in 2013. Red supported and encouraged me in my work for well over 10 years. And the Associate Dean of Emerging Media at the Tisch School of the Arts has been a mentor and was the first to suggest that I try teaching a course on processing, giving me a reason to start assembling programming tutorials in the first place. Shawn Van Every, current chair of the department, was my office mate during my first year of teaching full-time and has been a rich source of help and inspiration over the years. I am grateful to the support and encouragement of ITP professor. Her work on her upcoming book, Code of Music, oh, that's great, was deeply inspiring. Her innovative approach to interactive educational materials helped me rethink and redefine my own writing and publishing process. Yeah, I think in this world right now, the lack of material that you can learn is so minimum, especially when you try to learn interactive learning. So that's why I'm also create the pixeldeveloper.io, where you can learn to code by actually writing code. You are not watching videos or maybe read the article only, but you did the writing code as well. So I think it's great because whenever you try to code, you need to make sure your hands dirty, not just watching horse video, then feel productive, just nodding what they say in the video. So that's why I create this pixeldeveloper.io, and right now it's still one course, TypeScript Basic. And if you want to try it, you can get 50% of discount right now. And if you want to try it first, you can try the stem of fairy lessons here. Right? Okay, let's back to the nature of code. The vibrant and nurturing environment of ITP has been shaped by so many incredible whether they were college from the early days of this book. Okay, I think it's just the introduction. I'm also indebted. Yeah, I have many thoughtful, smart, generous, and kind viewers. I like to especially thank Deepam Sin. The book is so much better because of them. I also like to thank many people who collaborated with me over 10 years ago. Wow, it's insane. A special mention goes to Zanna Mars, who worked tirelessly to create over 100 illustrations. Wow. For the 2012 version of this book, and by some miracle agreed to do it all again for this new edition. Wow. I don't know. This book is really insane, guys, because you know that they create the illustration, they create the material as well, and it's free. That's insane. And there's some sponsor here. Thanks for the sponsor. Finally, a heartfelt thank you to my wife. Yep. Let's go to introduction section. Over a decade ago, I self-published The Nature of Code, an online resource and print book exploring the unpredictable evolutionary and emergent properties of nature in software via the creative coding framework processing. It's the understatement of the century to say that much has changed in the world of technology and creative media since then. And so here I am again with a new and rebooted version of this book built around JavaScript and the P5.js library. The book has a few new coding tricks this time, but it's the same old nature. Birds still flap their wings and apples still fall on our heads. I've been teaching a course titled Introduction to Computational Media since 2004. The origins of this class date back to 1987, and the work of Mike Miles and John in the course. Students learn the basics of programming, variable, conditional loops, object arrays, as well as concepts related to making interactive media projects. Concept related to making interactive media project, pixel, data, sound, networking, 3D, and more. In 2008, I synthesized my materials for this class into an introductory book, Learning Processing, and in 2015, I created a series of video tutorials that follow the same trajectory in JavaScript with the P5.js library. Once a student has learned the basic and seen an array of applications, their next step might be to delve deeply into a particular area. Maybe they want to focus on computer vision, data visualization, or generative poetry. My Nature of Code course, also taught at ITP/IMA since 2008, represent another possible next step. The course picks up exactly where my introductory materials leave off, demonstrating a world of programming technique that focus on algorithm and simulation. The book you're reading has evolved from that course. Yeah. My goal for this book is simple. I want to take a look at a phenomena that naturally occur in the physical world and figure out how to write code to simulate them. Wow. What then is this book exactly? Science book? The answer is a resounding no. True, I might examine topics that come from physics or biology, but I want to investigate this topic with a particularly high level of academic rigor. Instead, the book is inspired by actual events. I'm grabbing the parts from science and mathematics needed to build a software interpretation of nature, and fearing, of course, or skipping details as I see fit. I will say no regardless of how informal my approach might be. I'm still focusing on algorithm and their related programming technique. Sure, the resulting demonstration are visual, but they are literal visualization of the algorithm and programming technique themselves. Drawn only with basic steps and grayscale color. It's my hope, however, that you, dear reader, can use your creativity and visual idea to make new engaging work of the example. I won't complain if you turn every sketch into a rainbow. In the end, if this book is anything, it's an old-fashioned programming textbook, while a scientific topic may set a chapter and the result might inspire artistic project. The content itself will always boil down to the code implementation with a particular focus on object-oriented programming. Okay, good so far. A word about P5JS. The P5JS is a reimagining of the processing creative coding environment for the modern web. I'm using in this book for a number of reasons. For one, it's an environment that I'm very familiar with. While the original processing built on top of Java is my first love and still what I turn to when trying out a new area, P5JS is what I now use for teaching many of my programming classes. It's free, open source, and well suited to beginners. And because it's JavaScript, everything runs right there in the browser itself, no installation required. For me, processing and P5JS are first and foremost a community of people, not coding libraries or frameworks. Those people have generously dedicated countless hours to making and sharing the software. I've written this book for that community and for everyone who loves to explore their curiosity and play through the code. All that said, I think this book's content strictly to P5JS or processing. I think processing is one of programming language, isn't it? Processing is an open source programming language and integrated development environment designed for artists, designers, and beginners to learn coding within the context of visual arts. Oh, it's visually. Introduction to graphic in the processing. Yeah, it's like Canvas, I think. Canvas in JavaScript. Because with Canvas, we can have coordinate space where the origin start from here, not from center. And we can do something like this one. Yeah, I think it's similar thing with the processing programming language. For that matter, this book could have been written with vanilla JavaScript or Java, or with any number of other open source creative coding environment like Open Framework, Cinder, and so on. It's my hope that after I've completed this book, I will be able to release version of the example that run in other environments. If anyone interested in helping to port the examples, please feel free to contact me by email. Yeah, you want to port the nature of code to PHP. What? Go on. The nature of code to PHP. Really? PHP is server-based programming language, I think. I don't know. It's can visualizing what we code inside. All the examples in this book have been tested with P5JS version 1.9.0, but for the most part, they should also work with earlier versions. I will be keeping them up to date with the latest version, the most recent code. Yep. What do you need to know? The prerequisite for understanding the material in this book could be stated as 1 semester of programming instruction with P5JS processing or any other creative coding environment. That said, there is no reason you couldn't read this book having learned programming with a different language of if you never written any code before. While you could read the book for the concepts and inspiration, you will likely struggle with the code because I'm assuming knowledge of the fundamental variable, conditional loops, function, objects, and array. If these concepts are new to you, my code, but haven't worked, you can probably pick it up by booking through examples and reading. I should also point out that experience with OOP is fairly critical. I will review some of the basic in chapter 0, but if classes and objects are unfamiliar to you, I suggest watching my P5JS and processing OOP video tutorials, both also available at the Coding Train. How are you reading this book? Okay. My dream has always been to write this book in one single format. In this case, a collection of Notion documents, and then after pressing a magic button, in all format you want. Magic Book Project. Okay. There is also an abundance of exceptional educational material, teaching, simulation, and generative algorithm that I did not write or record. I'll always recommend that you explore various perspectives and voices when attempting to learn something new. Various perspectives and voices when it's possible that what I've written might not click with you, and even hearing me repeat the same information in video form, regardless of how mugging I do for the camera, won't help. Sometimes what's best is someone else you can relate to writing or saying or demonstrating the same concept in different words with a different style. To this end, I'm including additional resources section on this book website. Okay, the story of this book. If you glance over the book's table of contents, you will notice 12 chapters. Each one covering a different topic, and in one sense, this book is just that, a survey of dozen concepts and associated code examples. Nevertheless, in putting together the material, I always imagine something of a linear narrative. Before you begin reading, I'd like to walk you through the story. Part 1. Inanimate objects. A soccer ball lies in the grass. A kick launches it into the air. Gravity pulls it back down. A heavy gust of wind keeps it afloat a moment longer until it falls and bounces off the head of a jumping player. The soccer ball isn't a leaf. It makes no choices as to how it will move through the world. Rather, it's an inanimate object waiting to be pushed and pulled by the forces of its environment. How would you model a soccer ball moving in a digital canvas? If you have ever programmed a circle moving across a screen, you have probably written the following code. You draw a shape at position X. With each frame of animation, you increment the value of X, redraw the shape, and voila, the illusion of motion. Maybe you took it a step or two further and included a Y position, as well as variable for speed along the X and Y axis. Part 1 of this story will take this idea even further. After exploring how to use different flavors of randomness to drive an object motion, I'm going to take this X speed and Y speed variable to them and demonstrate how together they form a vector. And this is something I want to learn, because again, in motion canvas, it's a bunch of vector terminology that I found, like origin, what is the delta, this one, vector 2, what is the scalar. I know some basic math, like scalar is just a number to scale up or scale down our vector, but I still not have the mentally clear about what it does and why it's called scalar. So that's why again I try to read the nature of code to try to understanding factors and its related concepts. I think it's great book. Okay, you won't get any functionality of this, but it will build a solid foundation of for programming motion in the rest of the book. And it's great. Once you know a little something about vector, you're going to quickly realize that a force is a vector, kick a soccer ball, and you are applying a force. Ooh, that's force. What does a force cause an object to do? According to Sir Isaac Newton, force equals mass times acceleration. Apa itu konsep force dalam Indonesia? I think it's constraint, tekanan. Once you know a little something about vectors, force equal mass times acceleration. Mass time acceleration, so that force causes an object to accelerate. Modeling forces will allow you to create system with dynamic motion in which objects move according to a variety of rules. Now that soccer ball to which you apply a force might have also been spinning. If an object moves according to its linear acceleration, it can spin according to its angular acceleration. Understanding the basics of angles and trigonometry will allow you to model rotating objects as well as grasp the principle behind oscillating motion, like a pendulum swinging or a spring bouncing. Part 2, it's alive. Not an easy question to answer, but I will begin by building objects that have an ability to perceive their environment. Let's think about this for a moment. A block that falls off a table moves according to forces, as does the dolphin swimming through the water. But there is a key difference. The block can't decide to leap off the table, whereas the dolphin can decide to leap off. Oh, okay. The dolphin has dreams and desires. It feels hunger and fear, and those feelings inform its movement. By examining technique behind modeling autonomous agents, you will learn to breathe life into inanimate objects, allowing them to make decisions about their movements according to their understanding of their environment. Intelligent, you make things move, then you give those things hopes and dreams and fears, along with rules to live by. Wow, it's like a god. The last step in this book will bring intelligent decision making into your creations. Can you apply the biological process of evolutional to computational system? Randomness and vector forces. Code is the main medium of this book. Weaving throughout the narrative as it's an example, something that perhaps false. An example, let me drop Yes, a single unaffected stretch overall. We set up, we draw. And the generation of random number is too important to be left to chance. If it's been a while since you've programming JavaScript or done any math, for that matter, several will reacquaint your mind with computational thinking. To start your coding of nature journey, I will introduce you to some foundational tools for programming simulation. Random numbers, random distribution, and noise. Think of this as the first element of the array that makes up this book. A refresher and a gateway to the reality that lie ahead. To talk about the concept of vector and how it will serve as the building block for simulating motion throughout this book. But before I take that step, let's think about what it means for something to move around a digital canvas. I will begin with the mass known and simple notion of motion, the random walk. Balance beam expand your random walk from one dimension but you can use random walks to model all sorts of phenomena that occur in the real world, of molecules in a gas. The review of programming concept. Central to this book, the random walker I am about to create will serve as for using object-oriented design to make things that move around a computer graphic. The random walk instigates the two questions that I will ask. How do you define the rules that govern the behavior of your object, and then how do you implement these rules in code? Databasing and random probability and Berlin noise for this book's project. I will allow Berlin noise. Then allow me to demonstrate key points that will come in handy later. A bit of OP by coding a walker class to create walker objects that can go for a random walk. This will be only a cursory preview. We have never worked with OP before. Something more comprehensive, I should suggest stopping here and reviewing the an object in JavaScript is an entity that has both data and functionality in this case. Anyway, I think I need to end this live stream.